Go ahead, take a look in your closet. I'll bet you own something black. A t-shirt, some jeans, maybe a jacket. Black fabric is just everywhere. But have you ever stopped to think about how it gets that deep, rich black color? And how it stays that way? Well, let's pull back the curtain on that little secret.
It's a really fascinating story, actually. It's about some seriously clever chemistry that's over a century old, but is still woven into the clothes we wear every single day. The answer isn't some high-tech new discovery, but a reliable old workhorse that solved a very, very tricky problem.
So what is this secret ingredient? What's the chemical behind the world's most popular, most affordable black dye?
There it is, sulfur dye. Doesn't sound very glamorous, does it? But this compound is the unsung hero of your wardrobe. It's cheap, it's tough as nails, and the way it works is, honestly, kind of brilliant.
Okay, so what exactly is a sulfur dye? It's not just one single molecule. It's more like a big family of them, all defined by one very important feature.
So here are the two things you really need to know. First, it's held together by sulfur. And second, and this is the big one, it does not dissolve in water at all. And that insolubility is both its greatest strength and its biggest headache. It's what makes the color stick around after hundreds of washes, but it also makes it super hard to get into the fabric to begin with.
The whole process kicks off with a pretty straightforward reaction. You just take some sulfur and a chemical called p-toluidine, you heat them up, and you get this initial building block. Simple enough, right?
But here is where the magic really starts to happen. That first little molecule can link up with another one, and then another, and another. It keeps building on itself, creating these long, tangled, complex chains, we call them polymers, that become the final dye. And the bigger and more complicated this molecule gets,
The more it just hates water. So you see the problem. We've made this fantastic, super durable dye molecule, but it's basically a solid particle that won't dissolve. How on earth are you supposed to get a solid to soak evenly into the tiny fibers of a t-shirt? You can't. You need a trick.
And this, right here, this is where the real genius of the whole process comes into play. Chemists figured out a way to sneak the dye into the fabric and then slam the door shut behind it.
The absolute best way to think about it is building a ship in a bottle. You can't just shove a fully assembled ship through that tiny little opening, right? Of course not. What you do is you put all the little pieces inside and you build the ship inside the bottle. That's the exact same principle behind sulfur dyeing.
it's this elegant three-step dance. First, reduction. You add a chemical that breaks that big, insoluble dye molecule into tiny, water-soluble pieces. Think of it as taking the ship apart. Second, penetration. Now that the pieces are small and soluble, they can soak deep down into the fibers of the fabric. And finally, oxidation. Once they're inside, you add another chemical that makes all those little pieces reassemble themselves back into the big, insoluble dye. The ship is now built, and it is trapped inside the bottle forever.
And this isn't just some abstract theory, it's a very precise industrial recipe. This graph here shows you the actual process. See? It shows the exact moments where they add each ingredient and carefully control the temperature over time. It's this beautifully choreographed chemical reaction happening on a massive scale every single day.
So, this whole process is clever, it's cheap, and it works incredibly well. Sounds perfect, doesn't it? Well, like most things in life, it's a little more complicated. There are some pretty significant trade-offs. It really is a story of pros and cons. I mean, on the one hand, for a manufacturer, it's a dream come true. It's low cost, and the durability is amazing. But, on the other hand, you're pretty much limited to black and other dark colors. The process can actually damage the fabric if you're not careful. And yeah, the wastewater can be a pretty significant environmental pollutant.
Let's dig into that fabric defects point for a second. Because the chemistry is so specific, even tiny little errors in the recipe can lead to some pretty noticeable problems in your clothes.
So the first common problem is something called bronziness. You've probably seen this before. It's when a black fabric has this weird coppery metallic sheen to it. This happens when there's either too much dye or not enough of that sodium sulfide needed to break it down. The dye basically just crashes out and gets stuck on the surface of the fabric instead of getting inside where it belongs.
Now, a much more serious defect is something called tindering. And this is a slow burn problem. Over months or even years, the sulfur that's locked into the dye can slowly react with the air and moisture, and it oxidizes to form tiny amounts of sulfuric acid.
And you can probably guess having acid form inside your cotton fibers is not good. It literally weakens and eats away at the fabric from the inside out.
So, with these potential problems and the environmental concerns, you might be sitting there wondering, why on earth are we still using a dye technology that's over 100 years old?
The answer is really simple. Nothing else out there can deliver that perfect combination of a deep black color, incredible durability, and a rock-bottom price tag. It's the go-to for umbrella cloth that has to stand up to the rain, for the linings in boats, even for dyeing rubber. For thousands of products, its advantages they still outweigh the drawbacks.
And that leaves us with a really big question to think about. We've got this dye that is the absolute backbone of an entire color in our modern world. It is cheap, it is effective, and it is strong. But it comes with some very real baggage, both for the environment and for the quality of the products. So as we all look for more sustainable solutions, you have to wonder, what's the future for the world's most popular block?